Hey there, this is Samantha from Re3D. I'm here today in our operations building, and I'm honored to join the FGF User Group. Again, while Re3D does help facilitate this connection, this is really for the community, regardless of if you have a Gigabyte X or you're a Re3D customer. We're just hoping to have really great conversations around pellet printing and granular fabrication as we're all figuring this out. So as we've shared the last couple of months, we're always keen to bring in outside people to take recommendations on experts and influencers that everyone's connected to that we can learn from. So this week, we're so honored to have Aslinur Taskin, and she is from ADAXIS, and she's going to be sharing today. She has a really cool background. She's won multiple prizes, including the Danforth Indo Scholarship and the Peter Hans Visual Training Project Prize. And her background is interesting because she has a Bachelor of Architecture from the Illinois Institute of Technology, but also a Master's in Robotics and Advanced Construction from the Institute of Advanced Architecture of Catalonia. She's interned at a number of firms and has also served as a roboticist and fabricator at FabHub, in addition to her current role as an applications engineer. She's been received the new European Bauhaus Award, as well as the Project of the Year from Arc Daily in Spanish, which is phenomenal. So I've thrown her website in the chat here. If you have joined and don't see it, we can repost it. But it's really phenomenal. She's worked on some pretty cool projects I think you'll find inspiring, and we're very much looking forward to her conversation today on toolpath strategies for hybrid manufacturing.
Thank you so much. That's actually a really, really nice intro. But yes, I'm Aslinur, current applications engineer at ADAXIS, and before I was a roboticist, designer, artist, everything. And now I mainly work in toolpath generation and robotic manufacturing workflows with a variety of users and applications. So let's get right into it. What we're seeing today is that manufacturing is no longer just one process. We're combining additive, subtractive, and even scanning workflows. And it's really changing how we build complex parts. But to me, the problem is that most traditional design and CAM tools weren't really built for this kind of hybrid workflow. And as parts get more complex, they also need more adaptive strategies. And on top of that, a lot of current processes are still very manual, which makes them super slow, maybe error prone, and honestly a little bit hard to scale. So what teams kind of really need now, especially based off of some experience that I had with printing, is that we need something that's a little bit more automated to go from design and to actual manufacturing. And this is where ADA1 comes in. And so ADA1 is a software for programming robotic manufacturing processes. How do we actually approach this in practice? I would like to break it down into three different sections. First, 3D printing, scanning, and milling. So if we go into printing first, this is where most people first interact with ADA1. For printing, the main focus is really on controlling the deposition behavior. We use material profiles to quickly define the right setup for different materials and extruders and also nozzles, so you don't have to tune everything manually. There's also control over engage and disengage movements, which helps improve seams and overall surface quality. And finally, dynamic flow control, so the material flow adapts to the robot speed, keeping the deposition consistent. To support all of this, ADA1 provides a library of different printing strategies. So instead of working with a single approach, you can choose from a range of strategies from planar to non-planar, radial, and more advanced surface-based methods. This makes it much easier to adapt the tool path to the specific geometry and manufacturing requirements. The video that you're seeing on this screen right now was actually a workflow that we developed for JEC, which happened last week in Paris with the seed team. And it's actually going to be a part that I'm going to be showing throughout the presentation. But in this slide is a quick example of another a super simple slicing strategy. where we can define the process and adjust the parameters and generate the toolpath directly within the same environment. The idea is to keep everything connected and flexible so you can go from geometry to ready to print toolpath. Once the toolpath is generated, we can also visualize and better understand what's happening. So, for example, you can get direct feedback on how different parameters affect the result. So, like tool orientation, seam position, speed, overhangs. You can actually see how your inputs shape the final outcome, and it will help you make more informed adjustments. And speaking of optimizing complex parts, we took it a step further and integrated a thermal simulation and optimization through our new plugin with Helio Additive. It allows you to optimize the program based on both material and geometry by adjusting things like speed, flow rates, and temperature zones. So instead of relying purely on like physical trial and error, you can make more informed decisions early on in the simulation process and improve the print quality and consistency. And the cool thing about the Helio additive plugin is that all of the materials that they have, which are filament and pellet based, just to point out, they have classified default settings and they've stored them in their library. So you can access that to make sure that you have the correct settings that you want to use for optimizing. And beyond the general strategies, AdaOne also offers dedicated workflows for specific applications like mold and tooling. This workflow is designed specifically for LSM and it helps to streamline the process from geometry setup all the way to printing. You can quickly define tooling and support surfaces, and this is also supported by the fact that you are using files that automatically generates key features like edges, ribs, and supports. At the same time, you still have full control over all of the parameters like layer height, layer width, and the transitions. So you can fine tune the results based on specific requirements. And basically, what I've shown so far is more dedicated workflows, but we also have a dedicated plugin, which is kind of growing at the moment. But for now, this is what we have is to control the process between design and actually slicing. As we all know, the first step in any really, really good path is to be able to design for it. And that's where AdaSync it creates a direct communication between for now we have it for Rhino Grasshopper because I am a Grasshopper user myself. So basically it allows you to update your geometry, and when you do, you can push for that change into AdaOne, and your toolpath will be automatically updated based on the geometry update. And this process is supposed to make or this work is supposed to make your process a little bit easier and also more iterative if you choose. You don't have to keep saving, uploading, and etc. We are, again, as I mentioned, in the process of growing our plugins, but for the moment, we have started with Grasshopper. Um, so that was the design and printing side. I want to move on to the second step in a hybrid workflow, which would be the scanning. Oops. When it comes to scanning, the goal is to really make inspection as automated and reliable as possible. AdaOne can automatically detect compatible scanning heads and configure the process based on the setup. You also have control over key parameters like speed, resolution, and step over, which is similar to the parameters that you would have for printing. And that way you can also adapt the scanning quality to your specific needs and specific geometry. And depending on the application, you can generate either continuous or discrete scanning paths. Once the scanning head is integrated and the process is set up, which, by the way, all of the features that I showed before and also what I'm going to show is available already to be used in AdaOne. So nothing is an add-on and nothing is a plugin. Everything is open for use. The next step is really about how you generate scanning toolpaths. Just like with the printing, AdaOne provides a library of different scanning strategies from raster and surface-based scanning, especially if you're working with step files, to rotational and more manual approaches to accommodate working with STLs. This gives you the flexibility to adapt the scanning method to the geometry and the inspection requirements. And if we take this a step further, with a scan to mill workflow, we have a lot of dedicated workflows to different types of like processes, and this is one of them. The key idea is that the scan data can be used directly without needing to be remodeled in CAD. You can import the mesh or a point cloud, clean and align it, and then define machining regions directly on the scanned part. And from there, toolpaths can be generated using different operations, all within, again, the same environment to make the process a little bit more direct. And this is the final result for the video that you just saw before. The finished part that's been machined directly from the scanned data without going through a full redesign process. Since we have kind of seen the printing and the scanning, the final step in this is the milling outside of the scan to mill workflow. For milling, the focus is really on achieving precise and reliable machining behavior. We use tool libraries and material profiles to quickly define the right setup, the right feeds and speeds, for example, again, similar to our printing workflows. So you can get consistent results without extensive manual tuning. There's also control over engage and disengage movement, so you can design how the approach is and how the retract is going to be of the robot itself. And finally, dynamic toolpath control, which allows more advanced strategies like swarf machining and better tool orientation throughout the process. Once the machining process is defined, the next step is selecting the right milling strategy. And just like with the printing and scanning, we provide, again, a wide range of different strategies, more for standard operations like drilling and multi-axis, or let's say like planar finishing, to more advanced things like multi-axis approaches. This allows you to adapt the toolpath to both the geometry and the machining requirements rather than relying on a single workflow. And this is the part that I had mentioned previously when we had printed it. So we scanned it and then eventually we milled it to create a finish on the surface that we needed to have a finish. And to bring this into more practice, another example of generating a drilling toolpath directly in ADA1. From the process panel, you can define the machining strategy. In this case, the holes have already been designed as part of the actual part. So all you have to do is select the surfaces where the holes are. You can identify if you want to change the order at which you want to drill them. And that's just for the drilling. For all of the other milling strategies, we have different workflows available. In this case, also, it's easier to work with step. We are slowly accommodating to work with. It's already compatible with STLs. It's just that the surface selection aspect is something that we're still always working on and trying to enhance. And to tie everything together, we start from a 3D model or scan data. We move through configuration and programming, and then iterate through some simulation and optimization. From there, the process can move into printing, scanning, or milling. It doesn't, I mean, there's no specific order that you have to do. It really depends on the type of part or the type of setup that you have or what kind of goal you're trying to achieve with this part. However, we also have a beyond level, which kind of goes into monitoring and control and potential manufacturing reports, and then you're ending up with a final product. Before even running the program, we can also analyze and evaluate the toolpath performance. The performance rating is solely based on inputs from you about your setup. This could be related to maximum RPM, for example, allowed for your extruder, if you have some like material restrictions or other types of environmental restrictions, etc. This also gives you some insights regarding cost estimation, from operator time to material usage and even energy consumption. So instead of just generating a toolpath, you can assess and optimize and make a decision depending on how much this whole workflow is going to cost you before you move into production. And once the program is validated and running, we can monitor and control the process in real time through the manufacturing tab. You can connect directly to the robot, capture live data like motion signals and other process parameters. This gives you full visibility into what's happening during execution. So again, the robot is running and you're also able to see all of this data in real time on your computer. But also you can quickly identify any deviations. If needed, you can also make adjustments in real time. So that's sort of the end. Quick shout out to the team. We all come from different backgrounds. Not all of us are in the same time zone, but we are all working towards the goal to make hybrid manufacturing simple and efficient. This is where our headquarters are based in Bayonne in France. I myself am based in North Carolina, so I don't get this view often, but when I go to our headquarters, it's really nice to see. If you have any questions after this, I mean, we'll answer some questions now, but if you have any questions after this, feel free to reach out. Thank you.
Thank you for sharing. This is super, super cool. While we have the recording on, we'll open it up and see if anyone has any questions they'd like to share.
Okay. Should I stop sharing or should I keep this up?
You can keep it up in case we need to reference a slide.
Okay. I also don't see the Zoom window, so if someone is like
has their
saying
hand raised?
anything, I don't.
Looking. I don't see any hand raises at the moment. So what we'll do is we'll go ahead and conclude this part of the recording. And again, if anyone has any recommendations on future speakers, please let us know. And we'll go ahead and post this on our YouTube channel as well, as we have attendees usually from different parts of the world that will listen to the recording throughout the month. So we'll go ahead and stop the recording now.
Okay.